Welcome to Maths and Science by IITian channel. In this lecture, we will be talking about stable rolling, which involves three-dimensional analysis. Let us consider a motorcycle moving on a road and without toppling, with stable rolling, how this motorcycle should maintain a particular velocity so that if it slows down, it will topple. You might have seen motorcycles, when you drive very slowly, what happens? It loses its balance and it topples. Until now we have seen the topic of rolling without slipping. It is different from the rolling without slipping. It is a stable rolling where we are required to maintain a particular velocity. The wheels of the motorcycle can be either like a hoop or these can be circular discs, and we have to maintain a minimum velocity so that the vehicle does not get toppled. It's a very advanced topic. It's a three-dimensional analysis, hence I have taken it today because we have already completed on rotational motion about 13 chapters. Please refer to them before proceeding for the lecture. Please refer to them for any clarification. But however, I try to explain the maximum extent possible the relevant topics of 2D and put them in the 3D perception, and we will solve it. We should prove that the minimum velocity should be greater than square root of GA by 4, where A is the radius of the wheel and G is the acceleration due to gravity if a hoop is considered. Then we will solve the problem even for a circular disc also. Formula. This formula is for hoop. Let us take the case of hoop and proceed further. Let us draw a hoop and draw the x, y and z axis because we are considering in three-dimensional. Let us say it is x axis, it is y axis and it is z axis perpendicular to xy plane. Now, the moment of inertia for a hoop we have already calculated. I directly give the formula. Please refer to my earlier lectures for finding the moment of inertia of various shapes of rigid bodies. Moment of inertia of the hoop about the axis passing through its center and perpendicular to xy axis, passing through its center and perpendicular. Z axis is perpendicular to the xy plane. Please try to understand. This is the origin passing through its center and perpendicular because xyz axes are perpendicular to each other. This angle is 90 degrees. This angle is 90 degrees. This angle is 90 degrees. Xy is one plane, Z is perpendicular to the plane. I have explained this concept in my previous lectures. Please see them. Now, this refers to IZ, moment of inertia about Z axis. This refers to moment of inertia about x axis. IY refers to moment of inertia about y axis. We are consider xy plane and perpendicular to xy plane is Z. That's what is our consideration as far as this problem is concerned. You can consider any plane. For example, if you consider ZX plane, perpendicular to ZX plane is y axis. If you consider YZ plane, perpendicular to YZ plane is x axis. We are considering xy plane and perpendicular to xy plane is IZ. What is IX? Due to symmetry of the, because it is a circular tire, circular hoop, then due to symmetry Ix is equal to Iy. We are taking the xy plane. In the xy plane it is symmetrical and Ix is equal to Iy. And its value is equal to half m r square, where m is the mass, r is the radius of the hoop. Now, what is Iz? Perpendicular to it, due to parallel axis theorem. Apply parallel axis theorem. For this you please refer to my previous lectures on rotational motion. As per parallel axis theorem, Iz is equal to Ix plus Iy, that is equal to half mr square plus half mr square. Even in shorts I have given one shorts video on moment of inertia I have released. In that also, even in radius of gyration I have explained the regular video. That means if Ix is equal to Iy, if you take it as I, then Iz is equal to 2Ix, that is equal to 2Iy, that is equal to 2I. Ix is equal to Ix is equal to Iy is equal to I is equal to, we can refer to it as for the plane there will be a moment of inertia against tipping, because moment of inertia is nothing but a resistive parameter. It is a parameter of inertia. Inertia is nothing but resisting. It is for resisting the tipping. This is called as moment of inertia is about tipping axis, xy or tipping axis. Iz is equal to, we can call it as Is in this three-dimensional particular nomenclature. This is moment of inertia about the spinning axis, because tire is spinning about that perpendicular axis of xy. It is spinning. Are you able to understand? It is spinning like this. Spinning. Mi about the spinning axis. Z is the spinning axis. If you take YZ plane, then x will be the spinning axis, Ix. Ix is equal to Iy plus Iz. Depends upon xyz, you don't worry. If you take a plane, perpendicular to that plane is the spinning axis passing through center. This is the center. Iz is the spinning axis. The axis in the plane, because of the symmetry, Ix is equal to Iy, or you can say Iy is equal to Iz, or Iz is equal to Ix, whatever plane you consider, that is about the tipping axis. That is about the diameter. Ix or Iy. Now, you remember for this particular example, and if it is given in the examination to confuse you, then in that case you will remember it as a tipping axis or two axis, that is plane axes, and spinning axis is a perpendicular axis to the plane, Is and I. Now, what is Is? Relation between Is and I? Is is equal to, that is Iz, nothing but 2 into I for this particular case, from the symmetry for a circular hoop. We are talking about the hoop example now. There is one formula to find out the velocity. That formula is, it is derivation of the formula. I am not going into details. It's a very lengthy derivation. Please look for any standard textbooks for it. The formula you please try to remember. V square should be greater than I into mg a cube divided by is into is plus m a square. This is the formula, please remember. For toppling, the minimum velocity should be this much. Here, because it's a circular disc, A is taken as a parametric diameter or parametric dimensional quantity, parametric length. In a circular disc or a hoop, A is nothing but, in this case, for hoop or circular disc. In physics, we cannot say that R should be placed in place of A, because we have to find out A separately for different shapes. For a hoop or a circular disc, A is equal to R, that is radius, because of the symmetry. Because we are considering the shape, we are taking A is equal to R. Now some other shape is taken, then A should be different. That you do it as a homework. Find out A for different shapes, like a cone, what it should be, like any other shape, whatever you can think, and find out. Physics is general. Well, A is a general parameter. That general parameter for a circular disc or a circular hoop, it is R, radius. Now, what happens to this? V square should be greater than, I is how much? Half mr square, A is R square, A is R, I is equal to half mr square into mg into A is R cube whole divided by, what is is? mr square into is mr square plus mr square. A is R. This will be 1 by 2 half into m square r to the power of 5 into g whole divided by mr square into 2mr square. That implies V square should be greater than half into m square g into r to the power of 5 divided by m square into r to the power of 4. That is equal to, that implies V square should be greater than m square will get cancelled, r to the power of 4 will get cancelled and it will be 1. That implies V square should be greater than 1 by 4 into gr by 1. That implies V square should be greater than gr by 4. Here R we can take it as A is equal to R, so that V should be greater than square root of GR by 4, or V should be greater than square root of GA by 4. This is what we have got for a hoop. This is what is there in the first slide. V should be greater than square root of GA by 4. Now, if I take that as a lamina, second case, circular tire is a circular lamina or a circular disc. In this case, what is the Ix is equal to Iy is equal to, what is the value of Ix and Iy? One by 4 m r square. And what is the Is value? 1 by 2 m r square. How it has come? You do it as a homework. Now, what is our formula? V square should be greater than half ImgA cube, ImgA cube divided by Is into Is plus ma square. That implies V square should be greater than, what is I? That is 1 by 4 mr square into mg into r cube whole divided by Is is half mr square into half mr square plus mr square. This implies V square should be greater than 1 by 4 m square g into r to the power of 5 whole divided by 1 by 4 m square r to the power of 4 into 3. Because half mr square plus mr square is 3 by 2 mr square. 3 by 2 half we have taken already, half into half is 1 by 4 m square r to the power of 4 3. Then this implies V square should be greater than 1 by 4 is gone, 1 by 4 is gone, m square is gone, m square is gone, r to the power of 4 is gone. This becomes 1. GR by 3. V square should be greater than GR by 3. That implies V should be greater than square root of GR by 3, or V should be greater than square root of GA by 3. These answers don't get confused for rolling without slipping or road embankment. People usually get confused with road embankment. Those equations are different. And the values you get from rolling without slipping, they are different. If they become equal anytime, that depends upon the question. But velocity, we have done it for velocity. Minimum or maximum considerations we have done for 1, rolling without slipping, second for stable rolling, Third, for road embankment. Road embankment I will take up in the next class. All these are literally different. Don't confuse between them. This topic I have already discussed. Road embankment I will discuss in the next class. Hence, what we conclude, for stable rolling for a hoop, V should be greater than square root of GA by 3. A is equal to R. A is equal to radius. I have already told you because of the circular. Don't get confused because I used A. That is a convention. For a circular, for a hoop it is GA by 4. For a circular disc, it is V is greater than square root of GA by 3. These two you please remember. And do them for velocity considerations. The maximum velocity for rolling without slipping I have already discussed in the previous class. Please refer to it. This way you please compare. Don't get confused in the examination. If a question is asked either in JEE Mains or JEE Advanced, please, even in CSR also, CSIR, please see that these two, see the question, understand the question, and then answer the question. Next class it will be velocity considerations for road embankment. Next class, road embankment. Road will be given some slope whenever vehicle navigates a circular path. That we will be taking up in the next class. Best of luck to everybody. Thank you for listening to me. If there is a value addition to your knowledge because of this lecture, please share my videos and my channel name, and also kindly subscribe, share and subscribe to my channel. What is my channel? Maths and Science by IITian. This particular lecture will also be useful for Physics Olympiad, CSIR, Physics Olympiad, JEE Mains and JEE Advanced Physics, and NEET Physics. NEET Physics also it is useful. NEET Physics, JEE Physics, Advanced and Mains, then Physics Olympiad, and CSIR. Thank you for listening to me. Best of luck to everybody.